Hi, I'm Tom Dean, and I'd like to welcome you to this Buoyant Brown Bag workshop. In this hands-on workshop, we will deploy Buoyant Enterprise for Linkerd and demonstrate how to enable high-availability zonal load balancing. We'll then take a look at how HAZL works to keep network traffic in zone where possible by exploring some different traffic, load, and availability situations. Let's go ahead and take a look at our agenda. In this session, we're going to stay fairly high level. Today, we're going to take a look at what Linkerd is. We'll talk about Buoyant Enterprise Linkerd, including HAZL and Buoyant Cloud, which we'll be using to demonstrate HAZL. We'll do our hands-on exercise, and then we're going to wrap it all up. Let's get started. So, what is Linkerd? Linkerd is a large distributed load balancer composed of a management layer known as the control plane and microproxies that comprise the data plane, which are sidecar containers, one per pod. These microproxies intercept network traffic for the pod and manage that traffic. This is also referred to as a service mesh. So what do you get with Linkerd? Linkerd provides security, observability, and reliability with no changes to the application code and operates transparently to applications with no impact to availability. Now that we have a basic understanding of Linkerd, let's dig a little deeper and take a look at Buoyant Enterprise for Linkerd. So, what is Buoyant Enterprise for Linkerd? It's Buoyant's next level Linkerd service mesh distribution. Buoyant Enterprise for Linkerd, or BEL, gives you everything in open source Linkerd, plus things like enterprise hardened images, which are continuously scanned and tested and hardened at release. Strict SLAs around CVE remediation with guarantees around fixes with timeline assurances. Software bill of materials provide peace of mind and compliance by documenting all components, and comprehensive support options with support SLAs and regular planning and update meetings. BEL contains enterprise-only features such as FIPS compliance, lifecycle automation with fully automated installs, upgrades, and rollbacks, high availability zonal load balancing, which can dramatically reduce cloud spend in multi-zone environments by optimizing routing to avoid cross-AZ charges, security policy management, which helps generate zero trust security policies from existing application traffic, Buoyant Cloud, which gives you Linkerd monitoring, alerting, and management, and mesh expansion, which allows you to connect non-Kubernetes Linux applications to the mesh. So let's take a look at Buoyant Enterprise for Linkerd's architecture. There's a few major components we'd like to talk about. The BEL operator makes life easy by managing the life cycle of our Buoyant Enterprise for Linkerd installation. The operator manages the control plane and the data plane with its microproxies, and when you install the BEL operator, you get the Buoyant Cloud agent by default. You can also leverage extensions such as multi-cluster, SMI, and more. Let's dive a little deeper into the BEL operator. BEL includes a Kubernetes operator component that automates Linkerd installations, automates Linkerd version upgrades on both the control plane and the data plane, manages your MTLS certificates, is fully GitOps compatible working with Argo, Flux, and Helm, reduces manual intervention, and lowers the risk of configuration changes by doing error checking and validation prior to applying any of your changes. So, how does load balancing work in Linkerd? Well, remember, Linkerd is a large distributed load balancer at heart. Each microproxy is aware of the cost of sending traffic to endpoints, as well as the system load, actual and desired. Linkerd's goal is to keep load within the load band and only utilize costly endpoints when necessary, removing them from the pool at the earliest possible opportunity. No special tuning is required for most services, and decisions are made at the service and request level. This provides the cost advantages of single-zone clusters plus the HA advantages of multi-zone clusters. Let's take a closer look. Let me introduce you to HAZL. Buoyant Enterprise for Linkerd has a feature called High Availability Zonal Load Balancing, or HAZL, which is latency aware and defaults to keeping traffic in the same availability zone whenever possible while ensuring application availability. HAZL has the potential to save you a lot of money on cross-AZ spend without a lot of time and configuration required. With all that great stuff that's packed into Buoyant Enterprise for Linkerd, how do you make it better? Buoyant Cloud. We're going to use Buoyant Cloud for visibility in today's workshop. Buoyant Cloud is a one-stop shop for all your managed Linkerd service mesh needs, giving you monitoring, alerting, and management. Buoyant Cloud is also extensible to other products such as Datadog and Slack. We're going to get hands-on with Buoyant Cloud in our demonstration. In this demonstration, we're going to do the following. Deploy a Kubernetes cluster using K3D, which will then deploy Buoyant Enterprise for Linkerd on without HAZL enabled. We'll deploy our orders app and observe traffic, and then we'll enable HAZL and see the effect HAZL has on our traffic. We're going to scale traffic in some of the different zones. We'll add latency to one zone, and then simulate an outage in that zone and see what the effects are. Finally, we'll reverse the outage and latency and watch everything return to normal. In the scenario in this demonstration, we're delving into the operations of an online business specializing in hacky sack products. This business relies on a dedicated orders application to manage customer orders efficiently and ensure these orders are promptly dispatched to warehouses for shipment. To guarantee high availability and resilience, the system is distributed across 3 geographical availability zones: East, Central, and West. This distribution ensures that the system operates smoothly, maintaining a balanced and steady state across different regions. We're going to deploy the orders application on a fresh Kubernetes cluster, and we'll then deploy Buoyant Enterprise Linkerd and enable HAZL. Let's go. Okay, in order to get started, we're going to need a cluster, and I'm going to go ahead and use K3D to create one. And in the repository, there are some configuration files for different clusters. We're going to use this demo cluster orders HAZL YAML file to go ahead and serve as our configuration file. And we'll go ahead and kick that off. And let's go ahead and validate our work with the K3D cluster list. And we can see our clusters there. We're going to check our kube context real quick with kubectx. And we see that our cluster context in there, it's a little bit ornery and crazy. Let's go ahead and shorten that a little bit. So we'll go kubectx HAZL equals, and we'll grab this thing here. We'll just set it for a short alias. And now if we do a kubectx, we can see our context is HAZL. Now that we've got a Kubernetes cluster and context up and configured, we're going to go ahead and proceed with deploying Buoyant Enterprise for Linkerd. So the next thing we need to do is create our MTLS root certificates. We're going to use small step for this. I'm going to go ahead and cd into our search directory. And as you can see, there's no certificates in here. So we're going to use small step to go ahead and create those certificates. And now that we have our certificates, we're going to go ahead and create our intermediate certificate and key pair using those. So I'm going to run this command here. And now if we check our certificates here, you can see we have everything we need. So we're going to go ahead and change directory back to the root of our repository here so we can continue on. And now that we have our MTLS root certificates, we can deploy Bell. If we look at my directory, you can see I've got a file called settings.sh. I'm not going to show the content because my credentials are in there, but I want to go ahead and source that file so I can load those into variables, which Linkerd is going to then use during our installation process. I'm also logged into Buoyant Cloud, and as you can see, I don't have any clusters yet. This is a brand new, fresh greenfield to work with, so we're not going to do anything yet. But I just wanted to show you that we're starting with a nice, clean Buoyant Cloud with no clusters. So let's go ahead and change that. We'll go ahead and get our Bell installation underway. So the first thing I'm going to do is go ahead and install the command line. We do that with a curl and run that through shell. It's important that you set your path. You don't want to go hunting and pecking for the command. I've already got that set in my shell, so I'm not going to do that now. And just to check things, we'll do a Linkerd version to make sure everything's working. As we can see, our client version is the latest at this time of filming, and there's no server for it to talk to, so that says unavailable. It's exactly what we want to see. And prior to kicking things off, let's do a Linkerd check -- pre. This is a pre-installation check. We're going to make sure we got all greens, which we do. So we're ready to go ahead and start installation. So next we're going to go ahead and install the Bell operator, which we'll use to deploy the control plane and data plane objects. We're going to go ahead and run a couple of Helm commands. We're going to add the repo helm.buoyant.cloud, and then we're going to run an update on our repos. We've already got that repo here, but it's always good to make sure that you got what you need before you proceed. Let's go ahead and take a look at our installation command. We're going to run a helm install of linkerd-buoyant. We're going to create the namespace linkerd-buoyant where we're going to put stuff. I'm setting my context so that we make sure we're installing the correct cluster, even though I've only got one. I'm a little fanatical about that. We want to go ahead and set our agent name in Buoyant Cloud. I'm going to set that to the cluster name that I've got from my settings file, as well as the API client ID and secret. So all our Buoyant Cloud stuff should just pop up and work. I do have debug metrics turned on in here. It's just that I'm leveraging that for some other things that we're going to take a look at in the demonstration. So we'll go ahead and kick that off. And with the installation complete, I am going to go ahead and check the status of the rollout on our Buoyant Cloud metrics. And then we'll run a Linkerd-buoyant check, and everything looks good. We do have a couple warnings. It's not that big a deal. It's what we would expect at this point. We haven't injected proxies into anything, so it's just telling us that it doesn't see any proxies. We're good to proceed. Next, we're going to go ahead and take those certificates and keys we created with SmallStep, and we're going to use them to create a Kubernetes secret that will be used by Helm at runtime. So we're going to go ahead and create an identity secret file here. And if we take a look at that one, we can see we've stashed all that information in there, and we're going to go ahead and apply that to our cluster. And now if we do a kubectl get secrets on the namespace Linkerd, we see our identity issue or secret is out there. So we're good to proceed. So like I said, we're going to go ahead and deploy the Bell control plane and data plane using custom resources. We'll create a manifest for each that contains the object's configuration. We'll start with the control plane first. In this CRD that we're creating here, we'll go ahead and take a look at that. Control plane. We're going to use version Enterprise 2.15.2, and we've got our identity trust anchor in there. And right now we've got an additional argument that is disabled, and that is for HAZL. That's our -ext endpoint zone weights. Right now we're going to leave that commented out and disabled because we're going to start without HAZL so we can observe traffic prior to enabling it. So we'll go ahead and do a kubectl apply with our control plane, custom resource definition. And now if we do a kubectl get control plane, we can see our Linkerd control plane, and it's updating right now. If we watch this, we can watch until it finishes updating. And it's up to date. We're good to go. I'll break out of here. Remember, to make adjustments to your Bell control plane deployment, simply edit and reapply the manifest for the control plane CRD. Now that our installation is complete, we're going to go ahead and take a look at everything and make sure we've got everything up. And we do. We've got all the replicas up of everything in our Linkerd namespace, so we're good to proceed. And with that done, we'll do a Linkerd check once more to see where we're at. And again, we have not injected any proxies yet, so we do expect to see those warnings. Overall, our status checks are green, and we're good to proceed. So now we can go ahead and create a manifest for our data plane for our Linkerd-buoyant namespace so we can get rid of those pesky warnings. And if we take a look at that configuration here, you can see that it's named Linkerd-buoyant. We're putting it on the Linkerd-buoyant namespace, and we're going to basically match everything in that namespace. If you wanted to be more picky, you could match labels. You can do all kinds of things. You can annotate the applications to not ever be injected. There's things you can do to control this. So it's not just globally by namespace. You can enable it there, but there's ways to override that. So we'll go ahead and apply that to create the data plane for our Linkerd-buoyant namespace. And that's under management now. So again, you can run it without it being under management. You don't have to necessarily create the data plane, but that gives you the advantage of putting that particular namespace underneath the Bell operator's control. So you get things like MTLS certificate rotation. When you do upgrades, it's going to automatically roll your deployments and put new proxies in it. So there's a lot of advantages, that makes your life easier. And again, you get the validation and the safety rails, of the operator as well. So it's definitely nice to have, the operator watching your back on these things. And like we did with the control plane, you could do a kubectl get data plane on all namespaces. And we can see our Linkerd-buoyant Data plane is out there and we're up to date. Now, if we hop over to Buoyant Cloud, we can see some stuff finally, right? So we see we've got one Linkerd deployment, which was the one that we've just deployed with 5 mesh workloads, a total of 8 Linkerd proxies. If we go down here under Resources, Manage Linkerd, we can see our control plane here. Everything's up to date. We can see the spec on our control plane. Again, if you want to see the data planes we created the one for Linkerd Buoyant, and that's here, and it will give us the versions of the proxies that have been injected. Again, not everything in this namespace will get injected, just our cloud agent and cloud metrics. Excellent. So we've gone ahead and installed Buoyant Enterprise for Linkerd, and now we can use Bell to manage and secure our Kubernetes applications. So now that Bell is fully deployed, we're going to need some traffic to observe. We're going to go ahead and deploy our orders application. We'll go ahead and do a kubectl apply -k on the orders directory. Now that everything's been created, we can go ahead and run watch on this and make sure everything's up and running. My machine's pretty fast, so it beat me to the punch. We've got all our orders apps in Central, East, and West, as well as the warehouses that go along with those. And we can see that they're deployed alongside each other on the same node. That's the way we create availability zones within a K3D cluster. I'm going to go ahead and break out of this. We're going to launch a couple other things that I have a traffic check script that's in the repository. And what this will do is tell us where the traffic is going for each of these orders elements. Right now you can see they're all kind of evenly spreading traffic. So like East is going to all 3, Oakland, Chicago, and Boston, Central as well, and West. Without any load balancing, traffic is just going from each order location to all 3 warehouses across availability zones. I like to run this command so that I can keep an eye on the status of all the replicas of my various elements, as well as the status of my horizontal pod autoscalers that I put on the warehouses. As we play with load across availability zones, we're going to have the backend scaling to meet that. We're not doing a whole lot, but it's kind of nice to show, how everything works when it's not in a steady state and it's kind of moving and fluid, and how HAZL responds to that very well. Okay, so now that we've got it up and we're monitoring the application, let's go ahead and take a look at the traffic flow without HAZL enabled. We're going to hop over to Buoyant Cloud. Over in Buoyant Cloud, I'm going to isolate this by the orders namespace, which I've done here, and that'll give me everything in the orders namespace. I'm also going to change my edge label to request rate. As you can see, we're kind of spreading that traffic evenly. It's going to be somewhere from 15 to 18 for each leg, depending on the traffic at the moment. Right now, everything's talking to everything. It's one big, happy family. But what we want to do is kind of tighten that down and get rid of that cross AZ traffic. I've also got a nice Grafana dashboard that kind of summarizes everything in one place. And we can take a look at that also to observe traffic across AZ and to observe things like latency and success rate, and then requests by requester, such as by the orders, and requests, handled by the warehouses as well. Kind of gives me all the metrics in one place. Right now we're running, again, HAZL disabled, and we are just kind of generating some traffic here. You can see right now our cross AZ traffic is about 2 to 1 on the same AZ, which is what we would expect. Right now, for each requester, you're sending 2 requests for every 1 request out of your availability zone. Remember, all deployments are currently scaled to 1 replica, and the horizontal pod autoscalers have not auto-scaled yet. Let's go ahead and see what happens when we enable HAZL. So we can enable HAZL by modifying our custom resource definition for our control plane, and we'll go ahead and edit that manifest here. And like I said, down here at the bottom, we've got a comment or pound in here. If we remove that, that should go ahead and enable this additional argument, which will turn HAZL on. We'll go ahead and save that, and then we'll go ahead and apply our CRD to our control plane. And let's go ahead and see what happens when we do that. So I'm over here in Manage Linkerd in Buoyant Cloud, and you can see we're in a status of updating. But if you notice, additional args is turned on, and that's our external endpoint zone weights. So it's picked up the change, and now we're up to date in our status. all we did was change the configuration of our control plane. Again, if we were to go in and edit and say that Enterprise 2.15.3 was out and changed our version of our control plane and proxies to that and then applied it, we'd see the same thing. Basically the configuration of our control plane would change. It would go ahead and update those versions, and we'd then see the final status of that, is successful. And we just tell the operator what we want to do. We feed it the config, and, it handles everything else. If I fed it something that didn't make sense, it would tell me, no, I'm not doing that. That's an incorrect version or whatever I did, if I typoed. So it's nice to have the operator protecting you just in case you have a bad day. So if we go take a look again at the topology, we'll hop back into the orders namespace, and we'll go ahead and change that label to request rate. You can see things are starting to change. And there you go. We've got everything pinned in zone. So orders central is going to warehouse Chicago. Orders west is going to warehouse Oakland. And orders east is going to warehouse Boston. Now taking a look at our Grafana dashboard, you can see where things crossed over. And now we've got all our traffic in the same AZ and zero cross AZ traffic. You'll also notice that latency dropped considerably. We went from about 70 some milliseconds down to about 45 milliseconds. So we picked up, some advantage there. Requests by warehouse have stabilized out as well. You can see it was kind of popping up and down before, and that has smoothed out. And success rate is stayed at 100%. So we had zero interruption while we, enabled HAZL. Everything just happened transparently. Taking a look at the status of our deployments and horizontal pod autoscalers, we see everything is still set at 1 replica. If we take a look at the raw metrics here, we can see that, as the metrics continue to increment, that the metrics in the out of AZ for each one, like in East, Oakland and Chicago are no longer incrementing. Everything in East is just Boston traffic right now. So if you don't trust the GUI, you can go to the command line, run the script, and it'll tell you the tale that at this point, we're keeping all traffic in zone. So remember, our orders application is for our online hacky sack business. And a popular sitcom aired an episode in which the characters, a bunch of middle-aged Generation X folks like me, flash back to their teenage years and remember the joy they experienced playing hacky sack together. Our characters decide they're going to relive those wonderful hacky sack memories, and they go online to order supplies, featuring our website and products. Jackpot. So let's simulate what that looks like. Everything's going to air on the East Coast first. The first thing we would expect to see is an uptick of orders in Zone East, as they're the first to see this episode. We'll go ahead and simulate that by scaling our orders East to 10 replicas. And now if we take a look over here and see what happens, you can see orders East is scaled to 10 replicas. We'll keep an eye on Warehouse Boston, but I don't think we're going to crack horizontal pod auto scaling there. We're probably going to stay at 1 replica. And it's popped to 10%, but we're probably not going to crack that 25% threshold. Let's go ahead and take a look at what our increased traffic looks like in Buoyant Cloud. So we're over here in Buoyant Cloud, and you can see that our traffic has gone up between orders East and Warehouse Boston tenfold. And we now have 500.2 requests per second, exactly what we'd expect to see. Let's go take a look at Grafana. So over here in Grafana, we can see our same AZ traffic has increased, but cross AZ traffic is still at 0 bytes per second. Latency is holding steady, success rate is holding steady, request rate's gone up on both sides, on the order side and the warehouse side, just as we would expect to see in the places we would expect to see it. So next, we're going to take a look at scaling traffic in Zone Central. The middle of the country really liked our hacky sacks. Order volume is running more than double what we saw in the East. We'll go ahead and scale that to 25 replicas, about 2.5 times what we saw. And if we hop over here to our deployments, we can see that scaling up. Right now, Boston is still under the threshold. It hasn't triggered a horizontal pod autoscaler event yet. Let's see what happens with Central. And there we go. We've triggered an autoscale to 2 replicas on the warehouse Chicago. Let's go take a look and see what things look like in Buoyant Cloud. Over in Buoyant Cloud, we can see that Orders Central is pushing 1,200 requests per second over to Warehouse Chicago, and we're still staying in zone. And traffic is still staying in zone. Let's see what Grafana says. Grafana concurs. Same AZ traffic has increased, but cross AZ is still at 0 bytes per second. And we can see again, latency is staying steady at 45-ish milliseconds. Success rate's still at 100%. And we see our requests going up both from the order side and from the warehouse side. The Chicago warehouse is handling a lot more requests now, and Order Central is up as well. And popping back in to take a look at the status of our replicas and autoscalers. Again, we've got 2 replicas of our Chicago warehouse, and we're holding kind of just under threshold there. We're not firing a third one off yet. So everything's performing as we'd expect it to perform. And even though things are dynamically changing, HAZL's adjusting to that and keeping traffic where it needs to be. So by now, word of the episode is all over social media, and when the episode airs in Pacific time, orders in Zone West spike. So we're going to go ahead and scale replicas to 30 on that, and we'll take a look at the effect of that. Hop over here, where we're monitoring our deployments and horizontal pod autoscalers. We can see Orders West going up, and we'll keep our eye on the warehouse Oakland. See when that one fires an autoscaling event. West is at 30. We can see Oakland is about to approach that threshold there. And we're getting another replica of the warehouse. Let's go ahead and hop over to Buoyant Cloud and see what we can see there. Over in Buoyant Cloud, we can see our request rate in the West availability zone is now at 1,500 requests per second. Everything is still staying in zone. Traffic is happy. Costs are down. We're right where we want to be. Let's take a look at Grafana. Now we're really starting to get some traffic. So we're approaching 140 kilobits per second. Cross AZ traffic is still 0. It's actually fallen off the graph at this point. We can see latency is still hovering in the mid 40s and success rate still at 100%. We're not dropping anything. Requests by zone are up, with West topping everybody else, both at the order level and at the warehouse level. And again, taking a look at the status of our deployments and horizontal pod autoscaler, we can see Oakland has scaled to 3 replicas now in the warehouse, and Chicago's still at 2, Boston's at 1. So while everything's a little bit unbalanced between our different zones, traffic is still staying in zone, and HAZL is dealing with the imbalance just fine. So far, everything has gone right. What about when things go wrong? Unfortunately, we've had some network issues creep in at our Chicago warehouse. We can increase latency in Zone Central by editing the warehouse config map, which has a setting for latency. Let's go ahead and do that. Now, this application was originally an application called Color Wheel, so you can see there's 3 colors. Green corresponds to Chicago, so I'm going to go ahead and up the response time on green. Let's go ahead and change that from 020 to 0920. I'm going to save that. And then we're going to need to go out and do a rollout restart to have it pick up that config map change on our warehouse Chicago. So that's done. And let's go ahead and take a look at Grafana and see what we see. We can see latency is starting to spike, going over 4 seconds on our central zone. And we're starting to see some cross AZ traffic. And that's because HAZL doesn't want to sacrifice availability with this latency. It's going to start routing some of this traffic over to the other warehouses. And as you can see, requests by warehouse for Chicago are going down. Requests by warehouse for Oakland are going up. And we're starting to see an increase in requests on the Boston warehouse. Let's go take a look and see what the horizontal pod autoscaling and deployments look like. We can see that Oakland and Chicago warehouses are still scaled to 3 replicas, but we can see on Chicago that our load is down to 12% because we're not sending as many requests there due to the latency. We can also see now that Boston looks like it's about to fire to take up some of that increased load that's being routed away from the warehouse Chicago with the latency in place. Chicago is scaled down to 2 replicas since we're routing the order central requests to Boston and Oakland now. Let's take a look at Buoyant Cloud. We're over in Buoyant Cloud in the topology view, and let's go ahead and highlight what's going on in Orders Central. If we select Orders Central and we view the node topology, we can see that the majority of the traffic right now is going to Oakland. We're still servicing about 458 requests per second from Chicago, and we got a little bit of supplemental help here from Boston at 156.3 requests per second. So HAZL has kept our application online and servicing requests by routing traffic out of zone where there's capacity available in other zones. We'll go ahead and clear this. You can also see that Orders West is satisfying all the requests over here in the Oakland warehouse, and Boston as well. The Orders East is just pinned to Boston, so those have not hopped out of zone. Only Central, where we have our latency, has stepped out of zone in order to keep our application healthy and online. Well, our day went from great to bad to worse. The latency we've been experiencing is about to turn into an outage, and we'll go ahead and simulate that by scaling our replicas down to 0. Now that that's scaled, we'll watch everything develop here on our HPA and orders. Let's see what happens. So now Warehouse Chicago is scaled to 0 replicas. Let's go take a look at Grafana. So we can see a few things here. Latency has completely dropped because we're no longer trying to send traffic to the Warehouse Chicago where we had the latency problem. And even though it was servicing it, we were able to get, some capacity out of it. Now that it's offline, we're getting nothing. We can see that overall success rate is stayed at 100%. And we can see cross AZ traffic has gone up because now all the Orders Central traffic is either going to Boston or to Oakland. Let's go ahead and take a look at Buoyant Cloud and see what we see over there. So over here in the topology view, we see what we'd expect to see. Central is sending to Warehouse Oakland and to Warehouse Boston. Orders West is currently still being serviced entirely by Warehouse Oakland, and East is being serviced entirely by Boston, just as we would expect. Now you may wonder why there's a lot more traffic going to Warehouse Oakland than Warehouse Boston. That's because Warehouse Oakland has more replicas and can handle more traffic, and HAZL's aware of this, so it's going to direct more traffic over there. So once again, HAZL steps in and does what it needs to do, redirecting all the traffic from Orders Central across AZs to Warehouse Oakland to keep the success rate at 100%. Latency drops in the Orders Central as we are no longer sending traffic to Warehouse Chicago, which added latency. So good news, the latency and outage are about to end. We can simulate this by scaling Warehouse Chicago back to 1 replica, and we'll let the horizontal pod autoscaler take over. So I'm going to scale that to 1. We're also going to get rid of the latency. We'll edit our warehouse config map, and we'll change this back to 0.020. I'm going to go ahead and save that, and then we need to restart that deployment. Let's go ahead and see what's happening here in Grafana. You can see again, latency has come down. It hasn't gone back up because we brought that back online and solved the latency issue at the same time. You can see requests by warehouse are starting to creep back up on Chicago since it's back online. And we're going to see an effect of cross AZ traffic going down and same AZ traffic going up here in a minute. We'll let that time lapse here and you can watch it scroll by. And we can see cross AZ traffic has gone to 0 and all traffic is in the same AZ now. Requests by warehouse are starting to stabilize and latency is staying right around that 45 millisecond time while success rate's still at 100%. So again, along this whole entire timeline, as we scaled things and we introduced some chaos in, at no point did we have an outage. And if we take a look at Buoyant Cloud, we can see things have returned to the normal state that we had prior to introducing chaos. We've got, the heaviest traffic in the west. We've got some pretty light traffic in the east, and central kind of sits right in the middle of those two. Everything's back in zone. Everything's the way we want it. So, in today's demonstration, we took a look at Linkerd, including Buoyant Enterprise Linkerd, focusing on HAZL and Buoyant Cloud. We then dove into our hands-on exercise with HAZL, where we observed HAZL's impact under a variety of conditions. I'm Tom Dean with Buoyant, and I hope you enjoyed today's hands-on exercise with HAZL and Buoyant Enterprise Linkerd.